Hello friends, welcome to our channel Piping Mantra. Today we are going to learn about flare system and its major components. So without wasting any further time, let's get to it. In this video, we are going to cover topics like introduction of flare system, its applications, features of flare system, major components, equipment, etc. Types of flares, types of flare supports. So facilities like petroleum refineries, chemical plant, natural gas processing plants, oil and gas production sites with oil wells, offshore oil and gas rigs or platforms, petrochemical plants, landfills, anything accommodating pressurized hydrocarbons. These plants generate significant amount of waste products such as methane, volatile organic compounds, organic chemicals that have a high vapor pressure at room temperature, sulfur-related compounds, etc. Now, as per API 537, refinery or petrochemical plants are to ensure the safe and efficient disposal of relieved gases or liquids. These waste compounds are toxic, flammable, and corrosive in many instances and cannot be directly discharged into the atmosphere because of the following reasons. First, restrictions imposed by local ordinance or plant practices. Second, because of lesser permissible explosion or toxic threshold limit at a particular surrounding for local vents in plant. Third, in processes where long and severe waste exhaust temperature is anticipated, the gases cannot be vented locally because of hazardous condition. In such cases, the flare is the last line of defense for safe emergency release, as burning of excess hydrocarbon gas is a better option. For example, instead of venting methane to atmosphere, we can burn methane, which will provide carbon dioxide. As we all know, methane is 25 times more harmful than carbon dioxide towards global warming. Burning methane is a better option. The process of safely burning these waste gases is called flaring. In combustion, the gaseous hydrocarbon, natural gas, propane, ethylene, propylene, butadiene, butane, etc. reacts with atmospheric oxygen to form carbon dioxide, CO2, and water. Several byproducts formed will be carbon monoxide, hydrogen, and other substances dependent upon what is being burned. Efficiency of hydrocarbon conversion is generally over 98%. Now, let's discuss about features of flare system. When industrial plant equipment or piping items are overpressurized, the pressure relief valve is an essential safety device that automatically releases gases and sometimes liquids. The released gases and liquids are routed through large sloped piping systems called flare headers to a vertical elevated flare. Most industrial plant flares have a vapor liquid separator, also known as a knockout drum, upstream of the flare to remove any large amount of liquid that may accompany the relieved gases. This is done to avoid fireballs. A water-sealed drum to prevent any flashback of the flame from top of the flare stack is provided. An alternate gas recovery system for use during partial plant startups and shutdowns, as well as other times when required. The recovered gas is routed into the fuel gas system of the overall industrial plant. The released gases are burned as they exit the flare stacks. The height of the flame depends upon the volume of released gases, while brightness and color depends upon the composition. Steam is very often injected into the flame to provide an external momentum force used for efficient mixing of air with the relieved gases, which promotes smokeless burning, meaning reduction in the formation of black smoke. To keep the flare system functional, a small amount of gas is continuously burned like a pilot light so that the system is always ready for its primary purpose as an overpressure safety system. The flare stack, including the flashback prevention section at the upper part of the stack. So, the application of flare system is, flare systems are used for a variety of activities such as normal operation, that is during any overpressure scenario of plant process unit or equipment. Startup, due to the process upset or during startups and shutdowns. Plant maintenance projects and shutdown activities. Testing. safety, that is planned combustion of gases over relatively short periods, and emergency situations. Now, as we have seen briefing of how flare systems work, we will see the major components of a typical flare system. So, the system consists of piping, specialized valves, and equipment. Flare knockout drums, that is KODs, and its pumps to remove and store condensable and entrained liquids, proprietary seal, water seal, or purge gas supply to prevent flashback, a single or multiple burner unit, and a flare stack, along with gas pilots and an igniter to ignite the mixture of waste gas and air, and a provision of external momentum force, steam injection, or forced air for smokeless flaring. Let's see each component in detail. First is pipes and valves. So, these piping collects hydrocarbon released from waste gas via relief valves, blowdown valves, pressure control valves, and manual vents connected to different equipment like pressure vessel, tank, exchanger, etc., and disposes them at high temperature oxidation reaction by combustion at a remote and safe location with the help of gas combustion device called flare stack. We will see more about it in the later part of the video. This piping should be designed to have minimum pressure drop. Potential dead legs and liquid traps are avoided. Use of valves in this line should be kept to minimum, and when used should be car sealed to open position. The piping should be equipped for purging so that explosive mixtures do not occur in the flare system either on startup or during operation. Flare lines shall be in slope towards knockout drum and then towards the flare stack. Minimum slope of the flare header should be 1:450 as per API 521. It is general practice to have 45-degree branch connected to header via laterolet. Last, only 2D loops are allowed in the flare header. Next is knockout drum, that is KOD. This flare header has a two-phase liquid. A liquid knockout drum before flare or group of furnaces should be provided to prevent liquid from entering the burners. The gas and fluid separate partly first after hitting the deflector plate, and for those fluids that still settles at bottom, the gas comes up due to gravity. This prevents liquids from being discharged to the atmosphere. It prevents or reduces smoke because of reduced liquid in the flame. Increases flare tip life. It allows draining of liquid prior to flare. KOD may either be horizontal or vertical type. Horizontal KOD is preferred as the required elevation of the relief header will be lower than that would be required in the vertical drum, and thus this would result in a lesser cost option. KOD drum elevation decides pipe rack elevation based on 1:500 slope of main flare header. Knockout drum elevation is determined by pump NPSH requirement. Next is blowdown drum. More or less, the function of blowdown drum is same as KOD, but where the flowing liquid quantities anticipated are relatively low, a knockout drum will be sufficient and a blowdown drum may not be required. Blowdown drums tend to be located near the sources, close to the battery limits of a process unit or area to reduce the amount of piping subjected to two-phase slug flow. It is not a good practice to design for significant amount of liquids to run long distances through the plant in the vapor flare header. In general practices, these drums are sloped 0.33 in per 3.3 feet or 0.83 cm per meter towards the liquid outlet nozzle. A water boot may be required at the bottom of the horizontal drum to remove separated water from the liquid hydrocarbons. Now comes liquid seal. A flare system is subjected to explosion hazards when air is present in the system. Seal drums are used to provide a positive seal, thus preventing ingression of atmospheric air from the flare stack to the flare header. The reason for this seal is to prevent as much as possible the development of a combustible air or hydrocarbon mixture and thus prevent flashback in the flare system. The liquid seal drum is often a vertical vessel installed at the base of a stack. This image shows a vertical water seal drum. The water level in the drum is maintained by a constant supply of water. The relief gas inlet pipe is projected into the drum and immersed in the water to form a positive seal. Water from the drum is normally discharged into the oily water sewer system. The drum may require provisions for skimming hydrocarbon liquids from the surface of water. Removal can be either on the continuous or an intermittent basis. Water as liquid sealing fluid is not recommended for extremely cold releases, whereas water glycol mixtures of sufficient concentration is used instead. Next is flare stack. Flare stacks are primarily used for burning of flammable gases released by safety valves. Gas flares are used for startup, maintenance, testing, safety, and emergency purposes. In industries, the most common utilized flare system are ground flares and elevated flares. Selection of the type of flare is influenced by several factors, such as availability of space, the characteristic of the flare gas, that is, composition, quantity, and pressure, economics, investment and operating costs, public relations, and regulation. Ground flare. A ground flare is where the combustion takes place at ground level. Compared to the elevated flare, ground flare can achieve smokeless operation as well, with essentially no noise and no luminosity problems, provided that the design gas rate to the flare is not exceeded. However, it has poor dispersion of combustion product because its stack is near to ground. This may result in severe air pollution or hazard if the combustion products are toxic, or in the event of flame out, capital, operating and maintenance cost is high. Ground flare are mostly of two types: open ground flare and enclosed ground flare. Let's talk about open ground flare first. Here, flare headers distribute and the flaring occurs at ground, with the area surrounded by radiation fences. Most have multiple burners that combine large amount of gas to flare. The burners are located either in a refractory lined enclosure or in an open pit. Open ground flare can combust larger quantities than enclosed flares. Next is enclosed ground flares. Enclosed ground flares are the most practical ground flare type for industries located in the city areas. While they are expensive, they provide a means of smokeless combustion without a flame visible to the surrounding area. Hot combustion gases from an enclosed ground flare are discharged to the atmosphere through an opening at the top of the refractory lined enclosure. Now comes elevated flare. Elevated flare is the most commonly used type flare in refineries and chemical plants. These have large capacities than ground flares. This is similar to what we have used in college or school's lab as a gas burner. The waste gas stream is fed through a stack from 10 meter to over 130 meter tall and is combusted at the tip of the stack. The elevated flare can be steam assisted, air assisted, or non-assisted. Elevated flare can utilize steam injection, air injection to make smokeless burning and with low luminosity up to about 20% of maximum flaring loading. The disadvantage of steam injection or air injection is that it introduces a source of noise and can cause noise pollution. Capital costs are relatively high and an appreciable plant area may be rendered unavailable for plant equipment because of radiant heat considerations, usually up to 90 meter. Now let's talk about flare tip. Flare tip is a large burner or arrangement of smaller burners fitted at the end of flare risers. It provides safe and efficient burning of flare gases over wide flow. Flare tip is used for smokeless operation. The apparent density or opacity of smoke is defined as the Ringelmann number, where 0 is clear air and 5 is totally opaque. This can be hard to achieve at low flow rates, and therefore steam or air can be injected to reduce the smokiness. There are different types of flare tips available in the market, which are mainly open pipe flare tip, air assisted flare tip, multi-tip flares, Coanda flare tips, and high velocity or sonic tips. We are not going to discuss these in detail, otherwise this will be a very long video. Moving on to the next topic, which is gas barrier, either molecular or purge reduction seal or velocity seal. In most flare systems, either a molecular seal, also called a buoyancy seal, or a velocity seal is used at the base of the flare tip to ensure a minimum continuous flow of purge gas. This helps to avoid air ingress to the flare, preventing the opportunity for a potentially explosive mixture to develop in the system. Molecular seal systems rely on the differences in densities between the purge gas and ambient air to prevent the air from entering the flare system. The most common seal is an inverted can device that causes the gas that normally flows in an upward direction to be directed through a 180-degree turn at the exit flow. When this happens, gases lighter than air will tend to collect in the upper band of the apparatus, sealing off the stack against any backflow of air. Meanwhile, the heavier gases will tend to settle in the lower part of the band with the same effect. So, on your screen, the left diagram is for the molecular seal and the right one is for velocity seal. The molecular seal drum uses several concentric baffled cylinders to direct the exit gas and prevent air ingress. By comparison, the velocity seal is a cone-shaped obstruction orifice or series of orifices that is placed inside the flare tip to prevent the infiltrating air from hugging the inner wall. Velocity seals require a purge rate about 2 to 4 times higher than that of the molecular seal. Now comes the pilot system. As pilots and an igniter to ignite the mixture of waste gas. It consists of pilots, pilot igniters, pilot monitors. Let's talk about each one of these in continuation. First is flare pilot burners and pilot igniters. On flares, Environment Protection Agency, that is EPA regulations, requires a continuous flame to be present. This is provided with the help of continuous pilot burners designed for reliable ignition as well as stability. These pilot burners are positioned around the outer periphery of the flare tip. The pilot burners have to be ignited and an igniter is used for that. The function of the igniter is to ignite the pilots, which in turn light the flare burners. Now there are various types of flare igniters like electronic igniter, pressure igniter, that is flame front ignition, or combination of both. Now let's talk about pilot gas inspirator. Pilot gas inspirator are required for mixing of fuel gas with atmospheric air in a precise ratio to regulate burn characteristics. Here, only the pressure of the fuel gas is used to draw in and mix the air. An inspirator is a device similar to a venturi tube and an orifice plate. Now comes pilot monitoring. An alarm system warns that the pilot at the burner is out. This consists of a chromal aluminum thermocouple installed at the base of each pilot and connected to a temperature alarm switch. Loss of flame temperature then actuates an alarm switch. This pilot monitoring should be installed for each flare. Now let's discuss about types of flare based on mixing at flare tip. As we already saw during discussion of flare tip, an adequate air supply and good mixing are required to complete the combustion and minimize smoke. The various flare designs differ primarily in their accomplishment of mixing. Based on the method of enhancing mixing at the flare tip, the flares can be categorized into 4 types as steam assisted, air assisted, pressure assisted, and non-assisted. First we will discuss about steam assisted flares. Steam assisted flares are single burner tips elevated above ground level for safety reasons that burn the vented gas in essentially a diffusion flame. Steam-assisted flares are designed to dispose of heavier waste gases which have a greater tendency to smoke. Additional air is induced into the waste gas, providing the oxygen necessary for augmented smokeless capacity. Steam flares are typically used in applications where the customer has high-pressure steam available on-site. Now comes air-assisted flares. Some flares use forced air to provide the combustion air and the mixing required for smokeless operation. Air-assisted flares dispose of heavier waste gases which have greater tendency to smoke. Air-assisted flares can be employed at sites where steam may not be available. Additional air is induced into the waste gas, providing the oxygen necessary for augmented smokeless capacity. Constant airflow creates a cooling effect for extended flare tip service life. The amount of combustion air can be varied by varying the fan speed. Next is pressure-assisted flares. Pressure-assisted flares use the vent stream pressure to promote mixing at the burner tip. If sufficient vent stream pressure is available, these flares can be applied to streams previously requiring steam or air assist for smokeless operation. Pressure-assisted flares generally, but not necessarily, have the burner arrangement at ground level and consequently must be located in a remote area of the plant where there is plenty of space available. The last one is non-assisted flares. The non-assisted flare is just a flare tip without any auxiliary provision for enhancing the mixing of air into its flame. Its use is limited essentially to gas streams that have a low heat content and a low carbon or hydrogen ratio that burn readily without producing smoke. These streams require less air for complete combustion, have lower combustion temperatures that minimize cracking reactions, and are most resistant to cracking. Now let's discuss about type of flare supports. Elevated flares for onshore facilities can be supported in three ways. Self-supported flares. The self-supporting stack is a freestanding stack anchored to the base. Self-supported flare system is used for lower heights when radiation exerted is low. It uses less space for installation. It is more expensive than other designs because it needs greater material to ensure structural integrity over the anticipated condition. Normally, the stack height for the self-supported design was ranged from 60 to 75 meter. Next is derrick supported flare. Derrick supported only to be used when the stack is large and available land area is limited. That is, where guy wired supported is not suitable. The derrick supported stack is located in the center of a derrick structure and is held to the structure by tie rods and guides. Derrick supported flare can be built to a considerable height since the system load is spread over the derrick structure. Derrick supported flare system is optimum installation for higher heights where high radiation is exerted. This design provides for differential expansion between the stack, piping, and derrick. Derrick supported flares are the most expensive design for a given flare height. The derrick supported stacks have been built for around 120 meter height. Now, the last one is guide stack flare. The guide stack is anchored by guy wires. The guy supported flare is the simplest of all the support methods. However, a considerable amount of land is required since the guy wires are widely spread apart. Guy rope supported flare system is used when toxic gases are burned at medium height. A rule of thumb for space required to erect a guy supported flare is a circle on the ground with the radius equal to the height of the flare stack. These have been constructed up to a height of 180 meter. For flare stacks higher than 180 meter, a concrete support structure is required. The structural support systems for elevated flares in offshore facilities are the boom supported and derrick supported. The flare may be either vertical or inclined. The boom is an inclined support structure consisting of tie rods and guides. So that is it, guys. Thank you for watching this video. If you like it, then please click the like button and share it with your friends and colleagues. Comment your feedback, suggestions, or request a topic for your next video, and don't forget to hit the bell icon for notification. You can also follow us on Facebook, Instagram, and LinkedIn for more updates. So till next time, take care. Bye bye.